The question here is to sketch the graph of the function f given by f of x equals the floor function of cosine x, and see where does f have a removable discontinuity. So let me first recall the definition of the floor function, also called the greatest integer function and denoted by double brackets. It is defined for each real number a to be the greatest integer less than or equal to a. So this means that if a is between 0 and 1, 0 included, 1 excluded, then the floor function of a is equal to 0. If a is between 1 and 2, then the floor function of a is equal to 1, and so on. Let's now check what happens on the negative side. So if a is between -1 and 0, -1 included and 0 excluded, then the floor function of a is equal to -1. If a is between -2 and -1, -2 included and -1 excluded, then the floor function of a is equal to -2, and so on. What we're interested in here is the composite function f of x, which is the cosine function followed by the floor function. So this is the graph of cosine x in blue, and I'm gonna sketch in red the graph of the floor function of cosine x. First, since cosine x is 2 pi periodic, then the floor function of cosine x will also be 2 pi periodic. So it's enough to check what happens between 0 and 2 pi. Notice first, then, when cosine x is an integer, then the floor function of cosine x is this integer itself. So this happens when cosine x is equal to 0, 1, or -1. So at these points, at 0, cosine x is equal to 1, and the floor function of 1 is 1. At pi over 2, cosine x is equal to 0, and the floor function of 0 is 0. And at pi, cosine x is equal to -1, so the floor function of cosine x is -1. So at 3 pi over 2, the floor function of cosine x gives 0, and at 2 pi, it gives 1. So let's now check what happens between these points. So for example, on the open interval 0 pi over 2, cosine is between 0 and 1 strictly, so the floor function of cosine x will be equal to 0. So this point has to be excluded because the floor function of cosine 0 is the floor function of 1, which is 1 and not 0. Now between pi over 2 and pi, cosine x is between -1 and 0, so its floor function will be -1. This point is to be excluded, and the same happens between pi and 3 pi over 2. Between 3 pi over 2 and 2 pi, the cosine is between 0 and 1, so its floor function would be 0, except at 2 pi. So this is how we get the graph of y equals the floor function of cosine x. And we notice that between 0 and 2 pi, the floor function of cosine x has removable discontinuities at 0 and at 2 pi. So since it is 2 pi periodic, it will have a removable discontinuity at every even multiple of pi. So to conclude, the function f of x equals the floor function of cosine x has removable discontinuities at the points to k pi, where k is any integer. So these are the even multiples of pi. More precisely, f of 2k pi is the floor function of cosine 2k pi, which is the floor function of 1, which is 1, and the limit of f of x when x approaches 2k pi, and in this case cosine x approaches 1, of course from the left. In this case the floor function of cosine x is 0 and is not equal to f of 2k pi, which explains the removable discontinuity. So notice that the other discontinuities of the function f that occur at each odd multiple of pi over 2, as we can see here, are not removable discontinuities, but they are jump discontinuities.